Hey everyone, I'm Caroline Hughes, and today I'm talking about something that isn't always in the spotlight but plays a massive role in modern naval operations: electronic warfare, and more specifically, the software behind it. A lot of people picture missiles and big radar screens when they think of Navy ships, but so much of the real fight now happens in the electromagnetic spectrum, or the invisible environment where radars, communications, and sensors all operate. What's cool is that software is what actually makes this possible. So, my goal is to break down how ships disrupt enemy sensors, protect themselves, and make fast decisions using really advanced software. So, here's what I'm going to walk through today. First, I'll explain what electronic warfare actually is and the three major components that make it up. Then, I'll talk about two of the classic offensive techniques, jamming and spoofing, and how they actually work out at sea. After that, I'll move into how ships detect signals around them, how they protect their own systems when they're under attack, and then I'll show some real world Navy systems that use these concepts. Near the end, we'll look at the software behind everything and also where electronic warfare is headed in the future. It's evolving really quickly, so it's a fun area to explore. So, what is electronic warfare? Electronic warfare really has three big components, and each one plays a different role. The first of these is electronic attack, which includes things like jamming and spoofing, basically the offensive tools ships use to interfere with enemy radar and communications. The second of these is electronic protection, which is all about defending our own systems. Ships rely heavily on sensors, so we need to make sure those stay reliable even in a contested environment. The third of these is electronic support, which is like the ship's ability to listen. It picks up signals in the environment, analyzes them, and helps the ship understand what's happening long before anything shows up visually. These three pieces are happening at the same time, and they give the crew the ability to fight smarter, not just harder. So, what is jamming? Let's talk about it. Jamming is basically overwhelming an enemy's radar with so much noise that they can't get a clear picture. If their radar can't see you, they can't lock onto you or target you, so that alone is a huge advantage. Jamming can also interfere with communication signals. If the enemy can't share information or coordinate, that causes confusion on their end. But the really interesting part is how dynamic this is. Enemy systems switch frequencies constantly to avoid being jammed, so our software has to react instantly and shift with them. That's something that humans couldn't do fast enough, and it requires real time signal processing and automated decisions. Spoofing. Spoofing is the more deceptive side of electronic warfare. Instead of blocking the radar, you're feeding it false information or gaslighting them potentially. You can make it look like they are multiple ships when there's only one, or that your ship is somewhere that it's not. You can even trick an enemy radar into thinking you're moving a different speed or direction. This works because radars trust the signals they receive. So if you send something that looks legitimate enough and it's perfectly timed, the radar won't be able to tell the difference. And again, this all relies on extremely precise software. The system has to generate these signals perfectly and adjust them constantly to maintain the illusion. Electronic support. Electronic support is like the ship's early warning system. It's constantly listening for radar pulses, communication signals, and anything else that might reveal what's going on around the ship. It's basically building a picture of the environment before anyone actually sees anything. ES doesn't just detect signals, it figures out what type of signal it is, where it's coming from, what it might mean. For example, is it a search radar? Is it a targeting radar? Is it friendly? Is it hostile? Like all of the above. So, this gives the crew a huge advantage. The ship can prepare for threats long before they're visible on the radar. Electronic protection, or EP. Electronic protection is everything the ship uses to stay safe when someone tries to jam or spoof us. So, modern systems can hop between frequencies faster than a jammer can lock onto them, which keeps communication stable, even in chaotic environments. They can also detect if someone's trying to manipulate the GPS. A lot of systems rely on it, so the accuracy needs to be there so the ship needs to know right away if something looks off. What I really like about electronic protection is that many of these defenses activate automatically. They don't wait for a human to notice the problem, but rather the system recognizes the threat and responds immediately. Real world applications. So here are 4 real systems that show how all of this works on actual Navy ships. SUIP is the main electronic warfare suite. It detects radar signals, identifies them, and helps choose the right response. And then we have NOLCA, which is a really cool hovering decoy that creates a stronger radar signature than the ship itself. So incoming missiles target the decoy rather than the ship. Aegis is the Navy's integrated combat system where it ties together radar, weapons, EW together so the ship can react very quickly to threats. And then AN Spy 6 is the newest radar being installed on our destroyers, and it can detect more targets at longer ranges, built with strong electronic protection, so it's always reliable even if somebody tries to jam it. These systems show how deeply electronic warfare is built into our modern naval ships and like how prevalent it is. Um, so inside the software, even though we see antennas, radars, decoys on the outside, the real intelligence behind electronic warfare is the software. The system has to detect and analyze signals instantly. I mean, we're talking milliseconds, and compare them against the library of known threats. Once it understands what the signal is, it chooses the best response automatically. It also coordinates everything across the ship. So, sensors, countermeasures, decoys, and communication systems all have to work together perfectly. That level of coordination is way too complex for humans to manage in real time, which is why software is at the core of electronic warfare. So, what does the future hold? The future of electronic warfare is getting smarter, faster, and more automated. AI is being trained to detect signals that don't match anything in the library, which is huge because adversaries are always developing new radar systems. We're also seeing drones equipped with jammers and decoys. They can extend the ship's reach and keep humans out of harm's way. Decoys themselves are becoming smarter, able to adapt their signals mid flight, and cyber operations are blending with electronic warfare more than ever. The next battle space is going to be digital and electromagnetic at the same time. The systems are only going to get more complex, and software is going to become even more important. So, in conclusion, electronic warfare lets ships shape the battle space without firing a shot. Jamming disrupts enemy sensors, spoofing manipulates what they see, and electronic support and electronic protection help us detect threats early and stay protected. Behind everything is software. It's the part that reacts instantly, makes decisions, and keeps a ship one step ahead. It's one of the most sophisticated and essential pieces of modern naval defense, and it's all happening invisibly in the background. Thank you for listening, and yeah.